That was about a hierarchical key control. There is one simple concept included in your module 3, that is session key lifetime. Session key, as I told, session keys are nothing but the keys limited only to that particular session. One example I can see here is your what in your Linux operating system. We have different sessions there, right? You can log into students, administrator. So basically, one session will be included there. That is your guest session. You basically have the guest session option also. So what happens there in guest session? Whatever you do in guest session will be there only for that particular session. If you are shutting down the system and logging in again, that session will actually be deleted there. Whatever you have done, it will not exist at that time. So basically, with respect to session key lifetime, what happens here is it basically determines what is the lifetime of this particular session here. So we'll see how the working happens here. So this is actually one of the important part, that is explain the working of session key lifetime, or explain in detail session key lifetime. You should remember some key points in this. First, we'll see how the working happens. For connection-oriented protocols, one choice is to use the same session key for the length of time that the connection is open. This statement is just defining you to use the same key throughout the session. If I am using the same key throughout the session, you will have no doubt of using any other keys in between the session. So that is one important point. Using of same keys till the connection is being established in the session. You should remember that using a new session key for each new session. If I'm using a new key for each new session, what happens there? I can limit only one key for each session at the time. So the overall agenda is using of a same key or one key throughout the session. Throughout the session in the sense till the termination of session is not happening. So that is one point, usage of same keys throughout the session. Then that is one thing. That is, you can see the session key lifetime is divided into two sections. One is usage of same keys throughout the session. I'll come to this block further. We'll see the second point. So when can I use this same keys in this throughout the session is whenever the connection is with respect to the protocols. You can see connection oriented protocols. At this stage, I can use the same key. But for a connectionless protocols, there is no explicit connection or termination, that thus it is not obvious how often one needs to change the session key. So with respect to this stage, in the first stage, with respect to connection oriented protocols, you can use same keys in the in the throughout session. But with respect to connectionless protocols, you cannot use this. You can actually explicit the key, that is you can split the key into two parts and use that as an session key throughout the session. So how this part happens here, for a connection oriented protocols, for using the same key throughout the session, a security manager is actually initiated there. So what is the working of security manager here? Basically, he will balance some consideration of the keys which is being generated for the session. So you should remember, for connection-oriented protocols, a security manager is being installed or hired who will actually balance some considerations here. So what and all he can do with respect to connectionless protocols, the more frequently session keys are exchanged, the more secure they are. That is, so I can say this is one of the disadvantage of your session key lifetime. If I'm using the same key throughout the session, you'll have some advantage. What is the disadvantage there? You cannot change the keys so that you can work efficiently there. So what security manager tells here with respect to session key lifetime, to use different session keys or exchange the keys so that the security increases there. Then how the distribution of session key happens, the security manager defines it. The distribution of session keys delays the start of any exchange and places a burden on network capacity. That is, with respect to session key lifetime, there is a delay happening here, which is defined by the security manager. So what does he tells us? The distribution of session keys delays the start of any exchange. So whenever you are distributing a session key, there is a delay happening in the network. What kind of delay? Because in distribution, basically exchange of keys comes here. Whenever you are exchanging a key, it is actually an overload on a network. So what this overload defines? Basically defines the amount of work to be done by a network. So a security manager is giving some ideas with the help of which a session key can be managed. So if we keep these consideration in mind while generating a session key, so I can say the span of session key will be more there. Okay, you should remember session key is nothing but it is limited to that particular session only. So you can define at what time the session can end and at what time the session can begin. So that was simple about session key lifetime. So you can see this is one of the representation of key distribution for connection oriented protocols. So as I told, the session key lifetime is defined by two sections. One is for connection oriented, the other one is for connectionless protocols. For connection oriented protocols, what happens? This is actually one of the example with respect to a session key scenario or session key lifetime. I have used three different parts here. One is your host. You can see two different hosts I'm using, network as well as KDC, that is key distribution center. So basically, how the communication initiates is you can see there are interlinked. All the blocks are interlinked here, which basically tells you all are communicating with each other. Okay, so we'll see how the steps goes on. First, the application requests something with respect to the host. Whatever the application you want, whatever the working you want to do, that application is being sent to the security service, that is your host with the help of host. What does the security does? This request is being sent to the key distribution center. That is application in the sense, remember, I am requesting for a key here. So this request is being sent to the key distribution center. What next the key distribution center does is, this will communicate with respect to security service again. It will ask if the key is being asked to the security service. If asked, what happens next? If the key distribution center sees if the request, whatever key is being requested, if the request is pending in security service, that particular service is being sent to the network first. If not, so what happens? This key can be directly shifted to the host, another host, that is the another host you can see here. So this key distribution center does two parts here. That is, it will check for the service present in this security service as well as in this security service. Because I'm using two different hosts, it has its own security services. If it is there, it will actually provide that particular service to the application. So this is how the working happens with respect to key distribution for connection oriented protocols. Okay, so you can see the steps here. Host sends packet requesting connection. Security service buffers packets, ask KDC for session key. That is, request has been sent to the KDC. KDC distributes session keys to both the hosts. That is, first it will see the service is, if the service is there in these two hosts. If yes, again the key is being distributed here. That is, the session key has been distributed for both the host, that is this hostman as well as host. Then buffered packet is being transmitted. There will be one buffer initiated in the key distribution center. That buffer is being transmitted and shared to both the hosts here. So this is one of the simple example with respect to how the key distribution is being done in connection oriented protocols. Then with respect to session keys, we have another example which is actually taken as decentralized key distribution. So what basically happens in decentralized key distribution is basically the working is similar to your key distribution scenario only. You can see there is two initiators, initiator A as well as initiator B. In decentralized key distribution, what happens is basically KDC does not shows interest in such kind of key distribution sessions. You can see there is no key distribution center here. Basically, initiator A as well as responder B has its own a space where the keys are being actually stored. So you can say this is one of the advantage as well as disadvantage as well. So what is the disadvantage? There is no presence of key distribution center here. If what is the advantage of having key distribution center is basically whatever the key is being generated in the key distribution center are actually secure, that is highly secured then. If I'm taking the key from only the initiators as well as responders, the key is secured but not that much. When I compare the key security with respect to KDC, actually the security is lesser. So this is one part you should remember, the difference between using key distribution center as well as not using key distribution center. Okay. So what happens in decentralized key distribution is basically, as I told, there are two users. One is initiator A as well as responder B. So you should remember these two are not the same. These are the two different parts. Okay. So what initiator A does is first it will send the key to here. That is for decrypting some message, because the responder needs the key for decrypting some message. So with the help of ID, as you all know, with respect to key distribution scenario, basically IDs are very much important. Key size as well as ID of initiator A is being sent to the responder B. Once the responder B has this ID as well as number of keys, he can actually authenticate anything and extract the keys here. So it will basically encrypt the data from responder B and sends it to A, that is initiator A. So what happens in these states, that is the first and second stages, once the key is generated with the help of responder B, that key is actually used by initiator A also. Then finally, once you have that particular key, the final key is been decided by the initiator A, that is the third step, with the help of using functions. So as we all know, we have seen all these terms in the key distribution scenario. Only one difference what is being seen between these two is that is KDC is not being used in decentralized key distribution. With respect to key distribution scenario, key distribution center is very much important. So you can just give the same working of key distribution scenario without including KDC. So this is simple about decentralized key distribution.